Welcome to LIB Academy, and we'll be looking at normalization of the wave function with practical problems. The general Schrodinger equation, which is the fundamental equation in quantum mechanics, is a second-order partial derivative differential equation. So solution of this gives us something called wave function, which we usually use psi to represent those functions. And it turns out that solution from this gives us a lot of wave functions in terms of psi. Like any other partial derivative second order differential equation. Solution from it will give you a lot of wave functions. But Max Born said that the absolute square of the wave function should have something to do with the probability of us finding a particle in the system. And if we integrate from negative infinity to to positive infinity, which is the entire space, we must find the particle there. And the probability of us finding a particle there should be equal to 100%, which is 1. It shouldn't be 0.2, which is 20%, or minus 0.2, which is minus 0.2%. Because it turns out to be difficult for us to define probability in terms of minus values. It's kind of not making sense. So Max Born said that if we take the absolute square of the wave function and its conjugate, or the wave function simply integrate from negative infinity to positive infinity, or the entire space, the probability of us finding a particle within that space should be equal to 1, which is 100%. But because solution from the Schrodinger equation gives so many wave functions, some of the wave functions turns out not to give us a positive result to interpret. Can get negative probability. So to solve this problem, the wave function that should actually describe a row system should be positive, lead us to normalization of the wave function. Normalization of the wave function. And normalization of the wave function simply means that the wave function that is not normalized, we should add a certain constant to it and take its absolute square and integrate. Then after integrating, we should get 100% probability of finding the particle within the system. That is if the particle exists. And this n here, when we solve it, becomes a normalization constant. So in this case, we are looking for a constant that when we multiply by the wave function, will give us 100% probability of finding a particle when we integrate throughout the entire space. So in this case, this wave function, we can be able to use it to predict physical systems. And multiplying the wave function that we get from solution of the Schrodinger equation does not change anything, because it turns out that from second order partial derivative equation, if you solve and you get a solution, and that same solution you multiply it by a constant, it doesn't change anything. So that is what you need to know. If you found this video helpful, kindly subscribe to my channel and give a thumbs up to this video for more educational content like this. You can also refer my channel to your friends. Thank you. Bye.